kiddos, we're back and we're continuing to talk about bonding. In particular, we're talking about ionic bonds still, and this is the second half of that discussion. So just as a review, an ionic bond forms as a result of the transfer of electrons from a metal atom to a non-metal atom during a chemical reaction. Remember, folks, metal atoms are on the left side of the periodic table, and they tend to form positive ions by losing electrons. Nonmetals are on the right side of the periodic table, and they tend to form negative ions to attain a noble gas configuration. And obviously, we have positives and negatives, and they will attract each other, forming what we call an ionic bond. And that's due to the transfer of electrons from metals, who want to lose electrons, to nonmetals, who want to gain them. And as a result, we end up with charged particles, or ions, that are attracted to each other. The electrostatic force that holds the two ions together due to their differing charges is the ionic bond. Ionic compounds have the following properties. You're probably familiar with several. Ionic compounds tend to form crystals. If you're able to look at some salt under a microscope, or even without a microscope, even just looking at it sprinkled on the tabletop, you can see that they form these nice rigid crystal structures. You'll also notice that they don't form molecules. If we were to look at a sodium chloride crystal, we don't see individual molecules of NaCl. We don't see those molecules. Instead, we see a whole bunch of sodium ions and a whole bunch of chloride ions present in a 1-to-1 ratio. The reason it's a 1-to-1 ratio is because sodium atoms tend to lose one electron, forming a positive 1 charge, and chlorine atoms tend to gain one electron, forming a negative 1 charge. So we need one of each. So if you look at this picture, for every 1 chloride ion, you would see 1 sodium ion, wouldn't you? It's a 1-to-1 ratio. Now, of course, not all metals form positive 1 ions. Some of them form positive 2 ions. So calcium is one of those that forms a positive 2 ion. It loses 2 electrons. What if it got together with chloride that forms a negative 1 ion? Would that still be a 1-to-1 ratio? No, it would be a 1-to-2 ratio. So the formula for that would be CaCl2. That means that for every 1 calcium that you see in the crystal lattice, there would be 2 chlorides. Now we're going to talk more about writing these formulas in a later chapter. For now, I just want to show you that ionic compounds do not form individual molecules. They form a crystalline lattice, and we see a ratio of positive to negative ions. All right, ionic compounds have high melting points, and they also have very high boiling points. They often dissolve in water to form something called an electrolyte. An electrolyte is simply a substance that, when dissolved in water, conducts electricity. So I'm going to call that electric current. So a substance that, when dissolved in water, conducts an electric current. Ionic compounds are also hard, they're rigid, they are brittle solids. That means when I hit them with a hammer, they're not malleable, they don't bend, they actually shatter or crack, and we call that brittleness. Because the ions in the solid state are not free to move around, they will not conduct electricity. So when they're in the solid state, the ions cannot move around. However, when they're melted, they can flow past one another. Remember, we learned earlier this year that liquids can flow. So since the ions can flow past one another, they're free to move around, and they will conduct electricity when they are in their molten or melted state. In a later chapter, we will spend a lot more time naming and writing formulas for ionic compounds. Today, we're just introducing what ionic compounds are. Once again, it's important for you to know that ionic compounds are formed by the transfer of electrons from a metal atom to a non-metal atom during a chemical reaction. Let me just give you a few examples of ionic compounds. Sodium chloride is the most common. It's formed when the sodium atom loses an electron to form the sodium ion, and the chlorine atom gains that electron to form the chloride ion. We also saw calcium chloride earlier in this video, CaCl2. That forms when the calcium atom loses two electrons to form a 2 positive ion, and of course the chlorine gains 1 to form a negative 1 ion. Of course, we need 2 of those chlorides because they need to gain not only 1 but 2 electrons that are being lost by calcium. Let me give you another example. Aluminum chloride is AlCl3. Aluminum, as we know, forms 3 positive ions, or an ion with a +3 charge. It loses 3 electrons. To lose those 3, there must be 3 chlorine atoms that each gain 1 to become -1 chloride ions. And then things can get a little bit more exciting. Let me just give you one more as an example. Aluminum oxide is Al2O3. That is formed when aluminum atoms lose 3 electrons to form 3 positive ions, and oxygen atoms gain 2 electrons to form 2 negative ions. So you can see in this relationship, I would need 2 aluminums that would each lose 3 electrons, and 3 oxygens that would each gain 2 electrons to account for the 6 lost and the 6 gained. And we'll talk lots more about that in a later unit. For now, that wraps up ionic bonding for us. Okay? Short video. Talk to you soon. Bye-bye.